Hey there, everybody. Welcome back. This is 14.2 in our Calculus 3 course at College of the Sequoias. It's fall 2022. This section is on multiple integrals over non-rectangular regions, and let's just jump right into it. There's two ways we could set this up where, well, I guess there's three, where the boundary conditions on all sides are off. But the type, we're going to just focus on two for now. The type 1 is where the x boundary conditions remain constant, but the y boundary conditions are a function of x, as we can see on the left here. Orange is the shaded region that we're looking at. The other option we have is called the type 2, where the y constraints are still constant, but x is now a function of y along the x boundaries. So let's just focus on the left one first. The ideas transfer over easily between the two. If for the type 1 type, C and D, the boundary constraints on y must be large enough to encompass G1 of x and G2 of x, where we get the full region. For x in the region A to B, we don't want something less. Like we don't want the line to stop here, because then we're not getting the full region. We need it to be far enough out that we catch everything. Okay. The green region is 0. The area we're looking at is only the orange. So we could treat this as rectangular, where we're looking at C going up to G1x, the left line. That's less than the value in the middle, which actually has a value when we evaluated the function. And then G is less than D. This is going just left to right. But in terms of the function, the overall function, f of x, y, the green regions are 0. And so f equals 0 in those regions. Okay. So this kind of system is set up. So we still go from C to D, but since this is 0 here and this is 0 here, we might as well just shift our region to G1x and G2x as our boundary conditions. That way we're not having to break it up into 3 integrals. Okay, so we need to reset our limits of integration to match G1x and the second function, G2 of x. Okay. This is similar for type 2. We're going to realign our limits of integration. Our lower limit is h1 of y, and our upper limit is h2 of y. So we'll match that up to align with those. I'll show you some examples in the next video where it's a lot clearer. Peace.